Well, hello and welcome to another video. So, in the last video, we talked about what coroutine is, and actually, we created our own coroutine. We actually launched a coroutine inside a global scope. So, in this video, we are going to talk about suspend functions. So, if you see, let me just minimize this emulator, and if you see this delay function, and if you press Control and hover over it, it says it is a public suspend function, right? So the suspend function can only be called from within the coroutine or from within the another suspend function. So if I just cut this and paste somewhere in the on create function, it will give us an error, and it will say that suspend function delay should be called only from a coroutine or another suspend function. So we should put that back inside this, and we can create our own suspend function as well. So how we can do that? So to do that, we just have to write suspend function, and we can name it whatever we want, right? Let's just create a network call. I'm not actually going to call a network. I'm just going to return a string. This is a network call. Return. So now we can call this network function, which is a suspend function. We can call this from within a coroutine. So we can call this here network. Well, actually, it is giving us an error because okay, so that was a mistake. Calling a suspend function inside the onCreate. So I should have created that outside the onCreate method. Okay, so now we can run our application and see that this will work fine because we have called our network suspend function from the global scope of the coroutine from within a coroutine. So let's run our application and see if it is giving us this response or not. Well, actually, I forgot. Okay, let's see. What I forgot is I didn't actually uh, display the result of this query, this function. Actually, I didn't toast or log anything. So anyway, our application did not crash. That means everything works perfectly. So I don't need to actually toast this. Now let's talk about different context of coroutine. So there are basically four contexts. The first is main, which is used for UI operation. If we want to, change a UI, we should do that with main context. There is IO as well. Let me just show you. If I just talk about this, it will not click in your head. Instead, let me just show you. In when we are launching a coroutine with a scope, so we can define our coroutine context by writing dispatchers dot io main default and unconfined. So as I said, main context is used for UI related tasks. IO is used for any input output operations like network calls, any file related task, and so. And default, whenever you want to execute complex tasks that can hold the UI, but you don't want to, you can do that with default context. And unconfined, as the name suggests, it is not confined to any thread, right? It will just launch in the thread in which the coroutine initially was launched. So let's do one thing. I'm gonna make a network request. Actually, we do have a function for that as well that we just created. So that will be launched in the IO dispatcher. Sorry, IO context, right? That should be launched inside it. Let me just remove this delay. And now we have our, let me just take the result of the network call in the variable result. So we can print that in we can actually we are not going to print that. We are actually going to toast that, because I don't want to get into change giving the text view the ID and doing all this stuff. I'm just going to be toasting that. But as I just said, when we want to do something UI related, we should do that in the main context, right? So another cool feature of coroutine is that we can change the context of the coroutine whenever we want. So we made a network request in the IO thread. Now I want to change the UI according to the network result that I got from a network request. So I should change the context to main, right? So to do that, I'm going to write with context, and here dispatcher start main, and I can the context of the coroutine is now changed to main. Now I can toast here, toast dot make text this at main activity, and I'm just going to be printing this variable network result toast dot and short and dot show. Now we can just run our application and see how it works. We cannot see the result of how efficient the coroutine is from this little code. But if you have a lot of data, a network request if a network request takes time, it will be efficient to do that in the coroutine. And as you can see, little toast showed up in here, and the network request launched in the IO dispatcher, and our UI was changed in the main dispatchers. Both the threads were different, right? So this is how you play with the coroutine dispatchers. You can change the dispatchers whenever you want. It will basically change the thread. If network request will be asynchronous, and it will be in the different thread in the IO context, and the UI, the main context, UI will be changed in the main context in the different, I should say, main thread, right? So that's it for this video. I'll see you guys in the next video, where we'll talk about more things related to coroutine. Please subscribe to the channel and push the notification bell so you get the notification whenever I post a new video. And please share this video and like this video. I'll see you guys in the next video.